Okay, I've got sound, and this is the pre-recorded screencast that I mentioned in the email I sent to everybody about the schedule for this week, from this coming week, from Monday the 2nd till Friday the 6th. And I also posted that information in the announcements section. Okay, well, we're at module number 9, and of course, Fridays are virtual class. Wednesday and Fridays are virtual class days. I'll do a screencast Wednesday live stream. This, of course, as I told everybody, is going to be pre-recorded. Now, here's what we've got ahead of us this week. What's due by Friday is naive Bayes, and that's also Mandrill XLSS. And naive Bayes is from the Data Smart textbook, okay? And the naive Bayes starts over on page 77, okay? Now, we'll be working with the Mandrill file, and I have some information for you about this. And naive Bayes is essentially a use of probability, but different than using weighted probabilities. In the case of naive Bayes, we just simply assume that the probability of events is distributed on an equal basis, so we don't weight them. And this is an explanation of them, this PDF, and you'll want to take a look at it. Okay, here it is, and like I said, it assumes joint independence. Okay, in other words, that we have the chain rule of participation, and the probability of A times B times C up to how many ever P N. So we're going to see again in using naive Bayes, we're going to use it to create an artificial intelligence model, okay? And then we're going to create a decision rule. This is called the maximum a posteriori. And this is, for example, we assume 50-50 odds that a tweet is about an app versus that a tweet is about something else. So what we're going to do is build a rule here that lets us determine whether or not a tweet is about them Mandrill or their email application versus that it's not, that the email just is a spam or just of no consequence, okay? And then we convert the products. Now, I also have here for you all of the different Excel functions that are used in the case and what they mean, okay? And it's up to you, if you wish, to go ahead and do some more study on them. But we'll see how they're used here. See, we use natural logarithm. We use string text functions, a whole set of the VLOOKUP. So you're going to see these, and again, we'll come back on Wednesday and take a look because they're both going to be used. Now, I'm going to close this off, okay? And I want to go back to the modules. And this week, you also have due single arbitrary. Okay, so the Mandrill case, this is out of chapter 3 in the Foreman textbook. That's the Data Smart textbook that starts, it's chapter 3. And we're going to also look at the single arbitrary case that's due, okay? And let's move on down here. This is, of course, going to be module number 8. Now, before I go any further, the files that we will use for the Foreman, for the Data Smart or the Foreman text are over here in Files. And we'll just simply come in. We can actually even do a foreman. And we'll download that. And we're going to open up the files. And this will be for chapter. This will be the mandrel, excuse me. Here it is, mandrel. And I'm going to take it. I'm going to open it up. Enable the editing. And then I'm going to click Save As. And I'm going to put it on my desktop. And I put copy of mandrel. And I'm just going to put Keith. Okay, I'm going to put Harmon Keith. So you should have that. Now, I'm going to close this file. I'm going to find it over here. And I'm going to reopen it again on my desktop. Okay. And I'm going to save it again just to make sure that I have it on my desktop. Okay. And so we have it. Now, let's look up here. And I'm going to go back over to the module for this week. This is module or week 8, pardon me, 9. Okay. And here's what's due. 90 bays. That's the mandrel case. This is the case out of the Data Smart textbook that we'll work with. Single arbitrary. That's a case that's due. And that's what's going, and that's what you have due this week. They both are due Friday the 6th. Now, let's take a look for a moment at the single arbitrary case. Okay. And I ask you to use the goal seek to obtain the service cost per channel. And I give you to assume the weighting cost. Single arbitrary is going to move us into material that deals with queuing theory. Okay. And as I mentioned, you'll find the single arbitrary file in chapter 11. And again, these will be over in the files we've been using, the MS13 file, the MS13 zip file with a background in pages 519 through 520. So I ask you to simply do those things with single arbitrary. Now, let's go over for a minute and we're going to take a look at the single arbitrary. Okay. And we'll go down here to the MS13. You might even find the single arbitrary. Here it is. And let's see here. I want to find them. Here they are, the web files. And let's get the zip file. And the single arbitrary is over, I believe, on pages 519 through 521, if I wasn't mistaken. Okay. No, wait a minute here. Let's see. I'm going to open chapter by chapter. I forget. Excel. We'll take a look at this. We're still going to move through here. Oh boy. Okay. Let's keep going over here for just a second, because we're going to run into it eventually here. Or single arbitrary. It's down here in chapter 11. My apologies. And so you're also going to want to do this. Let's open up single arbitrary. Okay. And we'll enable that and save the file. And again, I'm going to put Harmon Keith, and I'm going to put it on my desktop, and I'm going to save it. Now, you'll want to note what I've asked you to do. So we're going to go back here, and here are the instructions for single arbitrary. And there's its backgrounds on page 519 through 521. And I'll do Control C. I'll come down to that single arbitrary. This is what we call a single channel. Okay. And I want to paste a text box. And I'll put these inside the text box. There you are. And so I'm going to ask you to use goal seek to obtain the service cost per channel. And like I said, the background for the case, this is a queuing theory case. And it's the background's over on page 519 through 521. All right. And I'm going to ask you to assume that the waiting cost, okay, per unit is $1.16. And to assume, and I'm going to ask you to use goal seek to obtain the service cost per channel. And you're going to put a target value on that of $2.99. Okay? So that's what you're going to be doing with single arbitrary. And I got that, of course, is due Friday. All right, so we'll go back here. Okay, and again, back we're on module 9. Okay, and we have we're working on this case, and we really have these two cases. We have Mandrill, okay, and we also have the that's from the Data Smart, and we also have single arbitrary. Now I want to take just a few minutes to talk about a single arbitrary. That's the one from the Anderson text, the big textbook, okay? And as I said before, the background for the case is over on pages 519 through 521, and they deal with what we call queuing theory, okay? And this is where when we have a situation when we have to serve customers in a queue, in other words, a waiting line. All right. Now, 519 to 21, this deals with what we call a single model, a single channel waiting model. Now, I'm going to go over here to a Vital Source where I have my textbooks, okay? And I'm going to pull it up, okay? And I'm going to grab the textbook for this course. And we'll go over to chapter 11. This out here for a second. And we'll talk about this model. Again, pages 519 through 521 in the textbook are the basis for this case, single arbitrary. And in this case, what they're saying is we have a single waiting line and an arbitrary service time. People show up and we serve them in a certain amount of time. Well, here's the book, here's the textbook. All right. And you should have your textbook again. As we go through these cases, as I discuss them, whether you're in class with me when I do the ground-based portion, or I'm doing a screencast, you got to have the book out and be looking at it and following along. All right, let's go down here to chapter 11. We do, of course, have waiting line, and we're going to look at a single channel waiting line. Okay, I want to start with the structures of waiting lines before we do anything else. Okay, you'll see this is over on page 504. Okay, and they walk us through waiting line systems. These are also known as queuing, the queues. And we have what we call a single channel waiting line. And this is where everybody's got to pass through one channel. For example, if Walmart had one place to check out, to pay for your purchases, that would be a single channel. If Walmart said your checkout time will take X amount of time, then that's what we call an arbitrary, a single channel arbitrary waiting line. And then we begin to look at the distribution of arrivals. Now, this figure 11.1 really does show us what's going on, okay, in this single arbitrary case. And they give us an example of a fast food restaurant, and the customer arrives, and they're put into line. They have a server who takes their order and then fills it. Okay, and the customer leaves after the order is fulfilled. Now, there are some key assumptions. For example, right here, where we assume that the arrivals occur randomly and independently of the others. When we talk about occur randomly and independently, then this starts to tell you how we see this in terms of the probability. And then, and as they mentioned at the top of page 505, and as I've mentioned throughout the course, not all data points or feasible or solution areas, feasibility areas are linear. We have those that are nonlinear, and we move into those when we deal with waiting lines, because they tend to look like a Poisson probability distribution, and that's more of like an S. Things kind of build up, and then they flatten out, and they build up. People show up for the lunch hour, then kind of taper off, and then dinner comes, and people kind of taper off. Okay, and we walk you through all of this, how that's computed. Okay, and so we're able to compute probabilities for one customer, no customers, two customers. Okay, and then we can see that. Now let's go back over. We'll go over here to page 519. Well, here at 509, okay, pardon me. All here we have exponential service times. We have more than one coming in, and we have to try to figure out when we have that distribution of customers when people are arriving at an exponential rate. Okay, now this is important because this helps mimic or model, if you will. You remember we talked about this is all about models. Arrival times at restaurants. So when everybody comes at 12:30. And they give us some good information there about arrival times, and you really do want to be on top of it, okay? And they walk us through the 2 channels, and we're going to get over to 519. We'll take a look at single arbitrary. Okay. And they show us the general shape for waiting costs. You notice it looks a lot like a cost model, total cost line, because it is. The total cost, the service cost, and notice as service cost goes up, waiting cost goes down. As waiting cost goes up, the service cost goes down. Those are choices that, of course, we have. The issue of total cost. Okay. So you're going to want to look at that material out of chapter 11. Okay. So that's the background, and that is over there in pages 519 to 521. Okay. Now, I want to go back to our single arbitrary. All right. And I'm going to diminish this down, and I'm going to open up this. This is a not the mandrel. I want the single arbitrary. Here it is. I'm going to open it back up. Okay. And I'm going to ask you to use the goal seek to obtain the service cost per channel. Okay. Now, I'm just going to walk this. Let's assume instead of $1.16 that the waiting cost per unit we're going to assume the waiting cost per unit is $1.18. Okay. And I'll put, let's say, oh, whoops, I put that in the service cost. But the waiting cost is 1.18. Okay. Now, I want to obtain a total cost per period. Here it is, of $2.99. Okay. So I'm going to go up here and I'm going to click on data. I'm going to go over to the what if analysis section. I'm going to go to goal seek. Okay. And I'm going to set the file here, pardon me, here. And I want that to be $2.99. Okay. By changing the cell we want to change the cell for service cost per channel. Okay, so we're using goal seek, and we want to set this cell C27, the total cost per period, to $2.99 by changing cell B25, which is the service cost per channel, and we're assuming here that the waiting cost per channel is $1.18. Now notice here the operating characteristics curve, the probability there are no customers in the system, average number of customers in the system, number of customers in the system L. These are the queues, waiting, how much time they spend in the system, the probability an arriving customer has to wait. We have all of those probabilities, and we'll look at them in just a minute. I'm going to run this. Okay. And it finds me a value. So if the waiting line cost is $1.16, then the service cost per channel has to be 85 cents in order to get a $2.99 total cost per period. Now, obviously, I used $1.18 instead of $1.16. All right. Now, here we have our arrival rates. Okay. And then let's look at this. Notice the probability there are no customers in the system. I would compute that. And these formula to compute the average number of customers in the waiting line. How many customers are in the system, which includes the waiting line and the people being served. Okay. And then how long average time a person spends in the waiting line. The average amount of time someone spends in the system as a whole. And again, as we looked at, I'll go back up over here. I'll go back over here in just a second. Remember that we have that single arbitrary model where a person arrives, they join the queue, the waiting line, then they are served, their order's taken, and it's filled, and they're done. That's a single arbitrary model. Okay, so I think this should be fairly explanatory, and the text does a pretty good job over there in 519 through 521 to explain it. And again, there's also an assumption that we have Poisson arrivals, which means that, again, it's kind of like stair steps or an S. It's kind of, let's say I'm running a restaurant and have a whole bunch of people show up for the morning for breakfast, and then it kind of tapers off. And then around lunchtime, the number of people who come in, that builds, okay? And it kind of flattens off, and then it becomes dinner time, and the activity builds up. You know, any service establishment has that kind of pattern. So we assume, okay, that we have that type of arrival. Now, when we talk about arbitrary service times, we're saying there's a set amount of time we have to serve each person. Okay, that's arbitrary. Well, that will, when we did this, and we got the total cost per channel. Now let's go back to the goal sheet. We'll do it one more time. Okay, I'm going to set this cell, C27, okay, to 2.99, okay, by changing this cell. And we'll run it, and we get the target value, which means the waiting cost per unit will be $1.18. The service cost per channel, and now we can, of course, you know, we'll be looking, as you would surmise, on multiple channels, okay, that means we have, like at Walmart, we have more than one place open for you to check out. And we're going to see that this understanding queuing theory is important if I'm running a service business or manufacturing business, because waiting line is important to customers. Well, I'm gonna click cancel on that, and I'm going to close this. I'm not going to save it because I want to spend some time talking about Mandrill. Okay, and again, it's due on the 6th of April, which is Friday the 6th, okay, and as is a single arbitrary. Now, before I do that, I want to point out some resources that I have here for you. First of all, I have a very interesting article here or a blog that deals with the case for the resurrection of Jesus. We'll just point this over. Okay. So take us out to this site. And this is a book. These individuals, okay, utilize probability theory, okay, in looking at the case as well as eyewitness accounts, etc. So it's an excellent book. Now, let me say this before I go on any further here, okay? And I want to get us back into the system. Back into Canvas. Because I had X'd this out. We'll go down here to the module. Let me note something. As we're going to see in the Mandrill case, this is over from DataSmart. The author does a fantastic job of introducing us or reintroducing us to probability theory. And then he does a fantastic job of telling us about Bayesian probability models. Bayes says, and this is called naive, that all events are independent, okay, and equally distributed. So if I have 3 events linked to some outcome, let's say, for example, the weather, naive Bayes says, okay, I'm going to look at probability of factor 1. That's 33% basically. Probability of factor number 2, 33% plus digits, and then the factor number 3, 33% plus digits equals 1. And of course, probabilities always have to equal 1. Or if I had 4 factors, the probability of it occurring would be 0.25. You get my drift. Now it's called naive Bayes because classic probability theorem says, oh, no, you've got to weight those probabilities, okay? And you have to look at whether they're dependent or independent. In other words, dependent, if one thing, before one thing can happen, one or more things must happen, okay? And we're going to see how we can use this naive Bayes technique to determine if the mail that these folks are getting, this is the Mandrill, whether these deal with tweets, excuse me, if the tweets are about the product or not. And we're going to build a predictive model, okay? Now, again, I want you to note, I provide you some explanation of Mandrill. This is the form and text chapter number 3. I provide you some resources about naive Bayes and types of error. Okay, and then I walk you through. Some notes about app tokens, how we come to those, and you'll see that as we work through it. App tokens for C2, and what we're doing is we're creating some tokens, okay, things we can count in order to compute probabilities. And then we're going to take a bunch of tweets that are about the product, some that are not about the product, and we're going to see if we can predict and how accurately we can predict if the tweet was about Mandrill, was about the application. This is what we call ex post facto analysis. And this wouldn't be too much different, okay? That if I say, okay, I'm gonna take, you know, everybody who died from, let's say, lung cancer, all right, and we get and they donate their body to science. The people are pathologists, people who study the disease, death, and the things that cause certain conditions. They're going to look at those folks to see if they can find factors, okay, or variables that contributed to that. And if those factors or variables are found on a uniform, on a consistent basis within everybody who dies of lung cancer, then we have something. Okay? So that's essentially what we're going to be doing. Now, we're going to see a lot of, we're going to see him using a lot of Excel functions, and I have notes for you that explain those. Okay? And then I have a link to a book that's a fantastic bit about a Bayesian analysis. Here's I think this is a YouTube. And then using informal Bayesian inference, and this is Bayes' theorem with the Lego. And then I have, and since we're talking about spam, I have a link that tells you about how much spam really impacts us and how much it costs us. So I got some good resources here for you to put the course in, to put the case, the case into perspective. All right, now I'm going to go ahead and I'm going to open the manual. Okay. All right, and we're going to go here step by step. Okay, and we have these are tweets that are about the app. Okay, these are tweets about something else. So we know which is which, and since we do, we can perform what we call an ex post facto analysis. That is, analyzing the data afterwards. Okay, and we can use that to try to build a predictive model. Then we have what we call tokens, how we create those, and we're going to go through each tweet, and we're going to look at the strings that are in them, space by space, and we'll count how much, and we'll get the length, okay, of that tweet, and we'll start at 0 space and go forward. Then we see the other tokens, these tokens, things we can count, and we'll see then the other tokens. Okay, and then the app token probability. All right, then the probability for the other. Then we're going to do some test tweets. Okay, and we'll do 10 that are about the application that we know they are, 10 that and then another 10 that we know are not. So you say, so you're saying that, Herman, we can go back and look at stuff that has occurred already, and we can help, and we can use that to help predict things in the future. Absolutely. One of the most difficult things in the world for anybody to predict is the weather. We do a remarkably good job of handling the weather and making forecasts. Okay. Now, something like a tornado, for example, we can't predict exactly where a tornado will occur. We can't predict if a tornado will occur. But what we can say is this, which meteorologists can say. We know the conditions in which tornadoes have a high probability of occurring. Okay? So that, in this Mandrel case, will let us see how to do this. Now, again, what we're going to do is we're going to take these tweets and we're going to do what we call some data wrangling. We're going to use some functions in Excel, okay, to clean these tweets up and get rid of the extraneous data in them. and only deal with what we want to analyze. Okay? Then, and we're going to do the same for the other set of tweets. Now, I think there's 150 of these tweets. Now, pardon me, there are 50 of them. Okay? And on Wednesday, we'll take a really deep dive into this and talk about it. Now, as far as a single arbitrary is concerned, that case, all right, and the queuing theory, you really do want to pay attention to chapter 11, because it walks you through each of those models. And we're going to be, in fact, we'll be working with we'll have some cases that deal with waiting time. It's extremely important because we know customers will only wait for a certain amount of time. Okay. Now, let's take a quick look at this first tab called About Mandrill. Now, let me say this, all right? Now, let me diminish this for a moment and go back into class. I have, okay, explanations for Mandrill, and that's what these files are here for. And so you're going to want to have them open, okay? You'll want to have your textbook with you. Pardon me, you'll want to have the textbook with you, the Data Smart text, so you can see how this is constructed. Now, I'm going to go through this on Wednesday, okay? And again, I've posted very extensive. I've told everybody what's going on with my schedule, okay? And so this is a screencast that's been pre-recorded. It'll be there for you, and so it'll be there for you on Monday, and I'll just simply leave the YouTube video in there. Now, I want to look for, this is the Mandrill for a moment, and I want to take a look at it. And we're in the About Mandrill app. So we know all of these tweets are about that application, about Mandrill, okay? And here's the full tweet, okay? Now we're going to begin to clean this data up. This is known as data wrangling, data cleaning, data prep, whatever term you want to use, but this is the process where we start to get rid of the stuff that doesn't matter. We're doing textual analysis here. And the reason I want to let you see it is so that you can see one of the ways that we handle big data, okay? And all of the different tools we have in Excel to get that done. So you don't have to use really fancy types of applications. You can use the functions in Excel. You probably won't be doing this for a living, but it's important for you to understand there are people out there like the Foreman's company, MailChimp, that help people with handling their email, right? Or this could be the same where, in this case, what we're doing is we're literally taking tweets, okay, 150 tweets about the product, 150. We're actually taking 300 tweets. We know which 150 are about Mandrill, the product. We know which 150 are not. And then, knowing that, we clean the data, okay, get it ready, we count it, we compute probabilities, and then we give a test. We test the model to see if how successful it is. Okay, and here we are, the test tweets and then the test predictions. And we'll see those. All right. Now let's take a look at this. First, we have this first tweet. All right. And now we're going to click on cell B2. And you'll see this is equal lower A2. What that means is, all right, we're going to take everything in cell A2 and we're going to use the lower function. We're going to put it into lowercase. Okay? And if you have the Foreman textbook and follow, he walks you through step by step. Okay? Not a big deal there. Now, in cell C1, in this case, if we find whatever we find in B2, okay, we substitute. Now, I'm going to click on this formula, and let's take a look at it. The text is going to be B2. The old text, anywhere we find a period, we're to convert that to nothing. There won't be any characters, numbers, letters, anything in there. So we've put everything in lowercase, then we get rid of any of the periods. Next, we're going to do the same thing. You can click on, we're going to substitute any semicolons for empty text. Again, we're cleaning the data up. We do the same thing to get rid of question marks and commas. As I said before, this textbook and this author, Mr. Foreman, is such a fantastic, incredibly fantastic tool, because he's using Excel to accomplish what other people pay a lot of money for in terms of products that are out there that can handle textual analysis. As I've said before, we've talked about this notion of big data, which is now a challenge for management scientists, is we have all of this what we call unstructured data, like tweets, like comments on products reviews, that we have to do something with. And we have to, because it may contain, usually does contain, some insights. In this case, we got rid of an exclamation point. And we'll look here. In this case, we're getting rid of, the comma. We're using the substitute function. And we're getting rid of, the commas here. So we're getting rid of here. That was a semicolon. And you'll notice we're always working by cell G. We're pulling the data from G2. We're getting the data from F2. And then here's H2. And we're getting rid of the commas. And then we have here in column I, okay, the cleaned up tweet. Okay. And so we have this cleaned up tweet, and that starts in column I. And there you are. We just repeat this process for each tweet. And this becomes then using the lower function, okay, and the substitute function. And it just becomes a matter of cell referencing, and away we go. Then we do the same thing here in the second tab where we look at about the other. These are tweets that we know are not about the product, but again, this is how we're going to be able to differentiate, because we're going to use what we call ex post facto analysis, which means analysis after the fact. We can learn from experience, okay? And that's what we're going to be doing. Okay, folks, now again, I want to talk about how to handle this. The naive Bayes, the single arbitrary is due 4, 6, That's Friday the 6th. Okay. And you can go over there. You can find it's from chapter 11 in the Anderson text. And I tell you what to do. Okay. And where to find the file, a single arbitrary file. Okay. And then what I want you to do is I want you to change these variable. The target variable here, see, we're using goal C. We're going to assume the weighting cost is 116. Our goal is a total cost per period of $2.99. So we want to use goal C to obtain the service costs per channel. And remember, when we're in queues, we have to deal with arrival time, we have to deal with service time, and arrival time plus service time equals the amount of time the customer or the person or whatever in the queue takes to be, the amount of time it takes to serve them. And that's why we can look at queuing as like the total cost. And as we saw, when service time costs go up, waiting costs go down. And think like at Walmart, you've got all these people going into a supermarket, going through with their article items. The more checkout stands are open, the faster people get served. But that means Walmart pays that much more to have somebody there. That's why they like you to go through and scan your own. Go get your own groceries, scan your own groceries, pay for your groceries, and leave. That's gold when you do that. Okay, and then the waiting costs. We know as service costs go down, the waiting cost goes up. And that would be, for example, if we have a really busy period at Walmart, but they only have 3 checkers open. They've cut their service costs, but the waiting time, but the waiting costs or time go up. Now, and we also know customers will only wait for a certain amount of time in any given service queue. Okay? Well, that's pretty much it for and this is for Monday, April the 2nd. I'll post it over there in the announcements section in Canvas. I sent everybody a long, detailed information about what's going on this week. Okay, and so this will be here as a pre-recorded screencast for you to take a look at. All right. Well, I'm gonna stop the sharing, and I'm gonna stop the recording and end the meeting.